So let's take another look at an exponential model word problem. So in this one, Ella deposited $2,500 into a savings account. The relationship between the time t in years since the account was first opened and Ella's account balance, b of t, in dollars is modeled by the following equations. We have b of t is 2,500 multiplied by e to the 0.025 times t. What will the balance of Ella's savings account be after 4 years? And we'll have to round our answer if needed to the nearest hundredth place. So with these word problems, since we have an equation and we have different variables, it's a good idea to start by just defining what those two variables represent. So t, usually but not always, represents time, or at least in this case, it represents time. And the unit for that is going to be in years. So it's a good idea to represent what its concept is, what is t representing, but also what are the units that you're using here. And then b of t, that is the account balance in dollars. So b of t, that is the account balance. So b for balance, and that will be in dollars. So we can just use a dollar symbol for that. So now that we understand what the variables represent, we can look at the question. So what will the balance of the savings account be after 4 years? So we're given the time. So it looks like time is 4 years, and we're asked to find the balance. So remember, the balance is represented by b of t. And specifically, since we're setting t equal to 4, we're trying to find b of 4. So that's our goal for this problem. And with this problem, if we first start by just rewriting our equation, we just need to set t equal to 4 and figure out what b would be equal to. And for this one, we really just can plug it in anywhere we see a t and solve. So b of 4 is 2,500 multiplied by e to the 0.025 multiplied by 4. So we just need to simplify this. Or at this point, we really can just plug this into your calculator, because to evaluate this exponential expression, you need a calculator to do that, since e is an irrational number and you're going to get a decimal answer. Though if you want, you can also simplify this exponent first, since we have 25 thousandths and we're multiplying that by 4. So we would have 100 thousandths, which is 1/10 or 0.1. So this is really equal to 2,500 multiplied by e to the 0.1. And like I mentioned, e raised to any power, this is going to be an irrational number. So the only way to figure this out is to use a calculator at this point. And when you plug this into your calculator, you get a balance after 4 years of $2,762. And we need to round to the hundredths place. So the decimal is 927,295 and so on. But again, we're going to round this to the hundredths place since we're talking about money. So we need cents here. So this will round it up to 3. So we have 27.62 and 93 cents for our balance. So that's what we can put as our final answer here. Now, if you do want a way to check this, there is a tedious way to approach this. And that's to work in reverse, to set the balance equal to what you think is the answer, and then solve for t. So we divide each side by 2,500, rewrite it as a natural logarithm, and then solve for t from there. And if you get an answer that is roughly 4, since remember this is approximate, if we get this as roughly our answer, then you can feel confident that you did this correctly. So that's a bit of a process, but it is a possible way to check it, since often solving the equation in reverse is, for one, good practice, but also just a way to verify that you're on the right track. So I will leave that as an exercise for you to try.